Okay, guys, cool. So I think we can start with today's class, right? So just to recap what we have done till now, right? So we have covered the two questions, right? Okay, did I not change my name? Okay, I'll just change my name, rename myself. Huh. Okay. So let's get started, right? And I think the best way to go forward, like what I have understood, is disable the charts in between, and then we can take questions once we cover a concept, right? So I think I'll disable the charts, and after some time we'll enable the charts, right? Once we are done with the concept. Okay. So disabling charts, right? Now let's focus on the class, right? Let me go to the PPT, and we can get started with our class. Just give me 1 second. Yeah. So just to give you a brief recap of what we have done till now, right? So we started off with the idea of sorting, right? And sorting was basically ki boss, you have to sort an array of integers in either ascending or descending order, right? And then in sorting, we studied about 3 different sorting techniques, which was bubble sort, selection sort, and insertion sort, right? So we studied about these 3 sorting techniques, and each of these 3 sorting techniques was big O of n square time complexity. And we had done a detailed analysis of all these algorithms, so I'm not going into them once again, right? Now, after we covered these 3 sorting algorithms, we started studying the topic of recursion. What was recursion? A function calling itself is recursion. And when can we use recursion? In cases of divide and conquer, where you see that you can break a complex problem into smaller subproblems, and after getting the answer to your smaller subproblems, you can get the answer to your bigger problem. In these cases, we were employing recursion. So we spent a couple of classes studying about the basics of recursion and understanding how recursive code actually works, right? So once we are clear with the 3 basic sorting techniques and we are clear with recursion, now we are left with 2 major sorting topics, right? 2 major sorting techniques that we have to discuss. The first sorting techniques that we will be discussing in today's class is merge sort, and tomorrow we will be discussing about quick sort. Okay. So that is the basic layout of what we are going to do today and tomorrow. Now let's get started with today's agenda, that is merge sort. Okay. So what is merge sort, right? As the name suggests, merge sort is a sorting technique. Okay. This is a sorting technique or a sorting algorithm. But unlike other sorting algorithms that we have seen so far, right? Merge sort employs recursion. Okay, there is an iterative version of merge sort also, but that is more difficult to understand. Okay, and the recursive code is much simpler to understand. So merge sort is based on recursion, right? So it employs the principle of divide and conquer. And today we are going to study this entire algorithm in detail. Now, before even I start to study merge sort, right? Or before even I tell you what is merge sort, how does merge sort work, and all the complexity analysis of merge sort, right? First of all, I want you to guys to understand a technique known as merging. Okay. And see, guys, I will spend 1 to 1 hour 15 minutes, right? Almost greater than half of the class in discussing about the concept of merging. Because once we are crystal clear with the concept of merging, merge sort will be like a cakewalk for all of us, and we will be able to understand it in a much better fashion, right? So let us get started with the concept of merging. So for this, I introduce a problem to you. Okay. So let's say you are given 2 arrays. Okay. I have 2 arrays, array A and array B. There are 2 arrays available to me, and each of these arrays is sorted. Okay. So array A is sorted. Okay. You have an array A, and this array is sorted in ascending order. Okay. Similarly, you have another array B, and this array is also sorted in ascending order. Okay. This array is also sorted in ascending order. Okay. Now, what I want you to guys to do is, given 2 sorted arrays, okay, I have 2 sorted arrays A and B. I want to merge these 2 sorted arrays into a new array C, such that array C should also be sorted. Okay. So I have a new array C, which should contain all the elements of A and B in sorted sequence or in sorted fashion, right? So I have to merge these 2 sorted arrays A and B into a third array C, such that array C is also sorted in itself. So what is my job? My job is to merge 2 sorted arrays into a third sorted array. Okay. That means array C should consist of all the elements of A and B in sorted fashion. Okay. So I think all of you will agree, right? The size of array C, what should be the size of array C? Array C is containing all the elements of array A as well as B in sorted fashion. So if I tell you, boss, array A has M elements and array B has N elements, can't I not tell you that the size of array C will be M plus N? Because array C will consist of the elements of array A and B. Both the array elements it will consist of in sorted fashion. And what will my answer finally look like? After I perform a merging of array A and B into C, my array C will be looking like this. See, 2, 4, 9, 10, 18, 19, 20, 23, 25, 30, and 48. Okay. So sorry for the small size, but this is how my array will look like. So array C will consist of all the elements of A and B in sorted fashion. This is what we want to do. Merge two sorted arrays into a third array. So array A and B are individually sorted in themselves. Now I have to merge the contents of these two sorted arrays into a third array C, which is sorted in itself. Okay. So this is the problem that we are gonna solve. Now let us try to look at an algorithm, right? How do we approach this process of merging? Okay. And then, we'll be a little bit more clear on what we want to do. So for your understanding, I am drawing the arrays top to down, right? It helps us to understand the algorithm more clearly. So array A is 2, 10, 18, 20, 23, 18, 20, and 23. Okay. And what is array B? Array B is nothing but 4, 9, 19, 4, 9, 19, okay, 25, 30, 48, 25, 30, 48. So these are the two arrays which are sorted in themselves. And I will be constructing a new array C, okay, which will consist of all the elements of A and B in sorted order. Okay. So if you want to understand, you can understand it like this also. Just I'm drawing the array in vertical fashion. Okay. This is array B. Okay. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So array C's size should be 11. Okay. Because array C will be in total containing 11 elements. So let me draw 11 boxes. 4, 5, 6, 7, 8, 9, 10, 11. I think this should be 11, right? Now, how do I perform this merging process, right? So what do I tell you? We generally employ a two-pointer technique, a two-pointer algorithm, okay? So what I will do is I have a pointer I. I have a pointer I at the starting of array A. So the value of I is 0. That is, I is present at the starting index of array A. Similarly, you have another pointer J at the starting of array B. So J ka value will also be 0. So I and J are basically the starting indexes of array A and array B. Okay, these are the starting index, okay, of array A and array B. Now, guys, can you tell me what should be the first element that comes in array C? The smallest out of array A and B? Boss, array A is containing some elements, array B is containing some elements in sorted fashion. And when I merge these two elements in sorted fashion, what should be the first element that comes in array C? Should it not be the smallest element out of both array A and B? Okay. And where is the smallest element for array A? Here at index number 0. Where is the smallest element for array B? At index number 0. So I have a pointer I here and I have a pointer J here. And what is the location that I want to fill? An index K. I will have a pointer K equal to 0, which will point to array C, where I have to fill the number. Okay. Now, what I want to tell you is, see, array A, what is the smallest number in array A? 2. So array A has 2 to offer and array B has 4 to offer. So what will I see? I will see, boss, array A has a number to offer, okay, which is 2. And array B also has a number to offer, which is 4. Now, what should I take out of these two? The smaller out of these two. So I compare. Is A of I, मैं क्या compare करता हूँ? Is A of I lesser than B of J? Okay. So I compare. Is 2 less than 4? Yes, 2 is less than 4. So what I will do? I will do, okay, go to array C, index number K. So C of K will be equal to A of I. So I write 2 here. And then what I will do? I will move K forward. Ki boss, I have written the element at index number 0. Now K should come at index number 1. Okay. And what I will do? I will move my pointer I forward. I will move this pointer I forward. Ki boss, I have already taken this element 2 from array A. So now let us move my index I forward. The next element that array A has to offer is 10. Okay. Now I ask you one question. Boss, I have taken this element 2 from here, right? So can I not take the element from B after this? Or do I need to compare again this element with this element? Anybody? Can you guys tell me? भाई मैंने 2 लिया ना, तो क्या तुम बोल सकते हो कि when you take an element from A, after that you take an element from B? Can I say it? No, because the first element of array B can be larger than the first 2 elements of array. देखो ऐसा हो सकता था ना कि if there would have been a 3 here, in place of 10, then you have to take another element from array A because 3 is less than 4. So everyone understands that you have to do a comparison before even you pick up an element. So now what you will do? Again, I compare these 2 elements. Okay. So see, I is at a valid index of array A and J is at a valid index of array B. So both the arrays have an element to offer. So what do? I compare A of I with B of J. I compare 10 with 4. What is smaller? 4 is smaller, right? 10 is not less than 4. So I know that I will take the element from array B. So what do? C of K is equal to B of J. So I will write 4 here. I will move K forward. Ki boss, the next location that I have to fill is this. And then I will move J forward. Why do I move J forward? Because I have taken the element from array B. So I will move my pointer J forward to see what is the next element that array B has to offer. Okay. Now, after this, what I see? Again, I is at a valid index and J is at a valid index. That means both the arrays have a number to offer. So again, let's do a comparison. You see that boss B of J is lesser than A of I. So what you will do? I pick up this element. So C of K is equal to B of J. So what I'm trying to do is, मैं ये comparison कर रहा हूँ. If A of I is less than B of J, okay, then what will I do? I do something like C of K is equal to A of I, okay, and then I move K forward and I move I forward. Else what am I doing? Else I am taking the element from B of J, okay. So I will take the element from B of J. So C of K is equal to B of J. I write 9 here. I do a K plus plus, go to the next position in array C. Okay. The value of K will be 3. Okay. And then I will do a J plus plus. Okay. J ka value becomes 2. Now again, I and J are both valid indexes. So both the arrays have a number to offer. So again, do a comparison. A of I is less than B of J. Yes. So this time I will take the number from array A. So what do? C of K is equal to A of I. I write 10 here. Do a K plus plus, K comes here. Okay. Do a I plus plus, I comes here. Okay. Again, what I will do? I and J are both pointing at valid indexes. So again, do a comparison. Is 18 less than 19? Yes, it is. So I will do C of K is equal to A of I. Take 18, move K forward. Okay. Move I forward. Again, you will see, right? I and J are both valid indexes, right? I is also at a valid index of array A and B is also at a valid index of array B. Okay, J, right? So again, I will compare A of I with B of J. This time B of J is lesser. So what I will do? I write 19 here. I move K forward and I move J forward. Ki boss, I have taken 19. Now let us see what is the next element that array B has to offer. Again, I see I and J are valid indexes. I compare both these numbers, 20 and 25. 20 is lesser. So I will say C of K is equal to A of I. So I write 20 here, move K forward, okay, and move I forward. Now, again, you see that I and J are valid indexes. So what you will do? Again, I compare A of I with B of J, 23 with 25. 23 is lesser. So I write C of K is equal to A of I. I write 23 here, move K forward, and I move I forward. Now, guys, try to understand. The moment you move I forward, you see that the value of I will become equal to 5. And if your array is of size 5, now 5 is not a valid index. That means I is now no longer pointing at a valid index of array A. That means you have taken up all the elements from array A. Now I tell you one thing, boss, you have exhausted your array A now. Now, whatever elements are remaining in array B, you can just take them as it is and copy. Why? Because see, all these elements which are now pending in array B now are greater than the last element that you took from array A. So now what do I need to do? See, array A has been exhausted, right? So array A does not have an element to offer. And array B still has elements to offer. भाई एक जन तुमको element offer कर रहा है and the second array is, one array is not offering you anything, and the second array is offering you something. So just take these elements, right? There is no point of comparison now because array A has been exhausted. So what I will do, I just take this element from array B, write it here. C of K is equal to B of J. Move K forward, move J forward. Okay. Then again, I take this 30, write it here. Move K forward, move J forward. Okay. Again, I take this 48, write it over here. Move K forward, move J forward. Now when I see boss, now J has also come to an invalid index. That is, both array A and B have become exhausted. Now, once you have exhausted both array A and B, you see that boss, array C is containing the sorted order. Array C is the merging of array A and B in sorted sequence. How many of you are clear with what we are trying to do? Let's see. What if arrays are not sorted? Assume for now the arrays are sorted, right? Clear? See, what I'm trying to say is, let me just, I'll just repeat it once again. Okay, this is something strange. Just one sec. Okay. Wow. We lost all the things here. Okay. Anyways, I think we can take another array example. Why did it happen? I don't know. Okay. So let me just try to repeat it once again quickly and shortly, right? So let's say you have an array, right? Let's say you have 2, 5, 8, 10. A very, very simple array, right? And let's say you have here 3, 7, 9, 11, 15. Something like this, right? So you have two arrays A and B, and array A and B are both sorted individually. For now, you have to assume that both the arrays are sorted, right? We don't abhi. If the arrays are unsorted, now then what you will do? You just write all the elements in array C and sort array C. But what I'm asking you guys is array A and B are individually sorted. So what should I do? Okay. So first of all, you need to have a third array, which should be able to hold all the elements of array A and B. So 4 plus 5, 9. So the size of array C should be 9 so that it can hold 9 elements for you. 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now what do I say? Boss, array A and B are both sorted in ascending order, right? So the smallest element of array A is present at index 0 here, and the smallest element of array B is present at index 0. So I take two pointers I and j and initialize them with the value 0. Okay. So I'm writing the pseudocode here, right? I is equal to 0, j is equal to 0. And I will take a pointer k and also initialize it with 0. Ki boss, this is the location of C that I want to fill. Now guys, try to understand what should be the first element that comes in C. The smallest out of A and B. So मैं क्या बोल रहा हूँ, boss, I and j are both valid indexes of array A and B, right? See, array A consists of 4 elements, right? So the valid index will be from 0 till 3. Okay. And array B consists of 5 elements. So the valid index will be from index 0 till index 4. Okay. So I and j are both valid indexes. That means both the arrays have an element to offer. So I will compare both of them. 2 is lesser than 3. Okay. In case of equality, you can choose from anyone. I don't care about that, right? So 2 is lesser than 3, right? So what will I do? I will first check, right? See, 2 is less than 3. So I write 2 here. I say C of K is equal to A of I. Okay. So I take this element, write it here, and then I move K forward. Now this is the next location that I want to fill. And because I have taken a number 2 from array A, let me move I forward. Let us see what is the next element that array A has to offer. Now, again, I and j are at valid indexes. You compare A of I with B of j. 3 is less than 5. So I will next take up 3 because I want to create array C in sorted order itself, right? So I compare both of them, 3 with 5. 3 is lesser. So I write 3 here. I move K forward and I move J forward. Let us see what is the next element that array B has to offer. Again, now you see that I and J are valid indexes. So I will compare the elements that both the arrays have to offer. I compare 5 with 7. 5 is lesser. So I take 5 here, write it, move K forward, move I forward. Now I comes at index 2. I and J are valid indexes. Let us compare. I compare B of J with A of I. 7 is less than 8. So I will write 7 here, move K forward, move J forward. Okay. Next. Again, I and J are valid indexes. I compare A of I with B of J. 8 is less than 9. So I write 8 here. I move K forward. I move I forward. Okay. Again, I and J are valid indexes. I compare B of J with A of I. 9 is less than 10. So I write 9 here. I move K forward. I move J forward. Right. Now, I and J are both valid indexes. I compare 10 with 11. 10 is lesser. I write 10 here. I move K forward. I move I forward. Now I has reached the end of the array. तो भैया एक array मेरा पूरा खत्म हो गया है. And whatever is the remaining part of the second array, those elements are greater than the last element of array A. See, 11 and 15, whatever elements are pending, they are greater than the last element of array A. So now I can simply copy all the elements from array B into array C. So what I will do, C of K is equal to B of J, move K forward, move J forward. C of K is equal to B of J, write 15 here, move K forward, move J forward. Job done. When J comes outside the array B, both the arrays have been exhausted, and you see that array C is consisting of the sorted order of array A and B. So you have performed the merging of array A and B in the sorted order. Okay. Is this making sense, guys? Is everyone clear with the algo? Why we are doing what we are doing? Yes. Okay. Cool. That's great. That's great. Right. So let us try to write a code for it. Right. Let us try to develop a code for it and see, you know, how we actually move forward, right? So let's go forward, right? So first of all, I will assume, okay, I'm just writing the pseudo code at this point of time. Okay. So I will assume that you have an array A. You have an array A that is sorted in ascending order. And let us assume that the size of array A is M. So array A ka size is M. There are M elements in array A. And let us say you have another array B that is sorted in ascending order. And the size of array B is N. So there are N elements in array B. Okay. And you already have created a new array C of the size M plus N. Okay. So I'm taking these three assumptions for now, that array A is consisting of M elements, array B is consisting of N elements, and you have already made an array C of size M plus N. Okay. Now let us try to write our logic. I'll just draw the arrays here briefly for our understanding. Okay, so let's say, what did we do? I have made an array C of size 8. Okay, whatever. So guys, tell me, first of all, I initialize pointers. So what should be the value of I? I will say boss I is equal to 0. Int I is equal to 0. Okay, so I is here. Then I will say int j is equal to 0. Okay, so j is here. And then I will say int k is equal to 0. So I have made 3 pointers which are the pointing at the starting indexes of array A, B, and C at the starting index, right? Ho gaya? Now, till when can I do a comparison? When both the array A and B have an element to offer. And when will both the array A and B offer an element to me? When I is also a valid index and J is also a valid index. So what do I write? While I is less than M. Is it a valid index for I? See, there are M elements in array A, right? So the valid indexes are from 0 till M minus 1. So while I is less than M, I is at a valid index of array A. Okay. And J is less than N. So if both of these conditions are true, guys, can I say I is at a valid index as well as J is at a valid index? That means both the arrays A and B have elements to offer. So what do? You do a comparison. So I will compare. If I compare. If A of I is less than B of J, I compare A of I with B of J. And if I see that A of I is less than B of J, then what should I do? I should take the element that is present in A of I and write it in C of K. So I will say C of K is equal to A of I. I have taken the element from A of I and written it in C of K. And then what did we do, guys? See, what did we do after this? We did a K plus plus and we did a I plus plus. Why K plus plus? Because I want to go to the next location of C, and why I plus plus? Because I have taken an element from array A. So let us move I forward. This is my if. Else may I want to take the element from array B. So what do? I say, boss, C of K is nothing but B of J. Okay. C of K is nothing but B of J. I've taken the element from, B of J, written it in C of K. And then what I will do? I will do a K plus plus and I will do a J plus plus. That's it. right? Now, let us try to trace it, right? Let us try to trace it and see what happens, right? So first of all, k will be equal to 0. Okay. Now, what is the value of m? M is 4. And in this case, we have taken, n also equal to 4. But they can be of different sizes as well. So, is I less than 4 and j less than 4? Definitely. That means both the arrays have elements to offer. So you compare. Is a of I less than b of j? No. So I enter into the else block and I say c of k is equal to b of j. So I write here 2. I do a k plus plus. I do a j plus plus. Done. Again, I come to the while loop. I check. Is I and j valid indexes? Yes. I is less than 4 and j is also less than 4. Right? So again, I compare. Is a of I less than b of j? No. So I enter into the else block. Write c of k is equal to b of j. Do a k plus plus. Do a j plus plus. Right? Then again, I go to the while loop. Is I and j valid indexes? Yes. Both of them are valid indexes. So again, I will compare. If a of I is less than b of j, yes, the if condition hits to be true. So I will say c of k is equals to a of I, do a I plus plus, sorry, do a k plus plus, do a I plus plus. Okay? Now, let's take one more element here. 50. Okay. Now, again, I will see, okay, I and j are both valid indexes. Do a comparison right here. Do a I plus plus, do a k plus plus. Again, you will go to the while loop and see. I and j are both valid indexes. So both the elements, both the arrays have elements to offer. So again, I compare a of I with b of j. 10 is lesser than 25. So I will say c of k is equal to a of I. So I write 10 here, do a k plus plus, do a I plus plus. Again, both are valid indexes. You compare 11 less than 25. You write 11 here, do a k plus plus, do a I plus plus, right? Again, I and j are valid indexes. I do a comparison. This time, b of j is less. So I will write from b of j, do a j plus plus, right? Again, I and j are valid indexes. Do a comparison. Right here 30. Do a k plus plus. K comes here. Do a j plus plus. Now, guys, try to understand. When will you come outside this while loop? The moment either one of the arrays finish. Okay. The moment one of the arrays finish, right? The value of I will either become m or the value of j will either go to n. See, now j has become equal to 4. It is outside the valid index of b. So we will come outside this while loop when either I becomes equal to m or j becomes equal to n. जब एक भी array खत्म हो जाएगा ना, then you come outside this while loop. Okay. So outside this while loop, I know that one of the arrays has terminated and one of the arrays still has elements that I have to copy. So what do? I don't know which array has finished or which array has not finished, right? So मैं क्या करता हूँ? I write two more while loops. कि boss, while I don't know whether I has terminated or j has terminated, right, at this point of time. So let us do while I is less than m. Okay. So if array A is pending, if I is lesser than m, that means array A still has some elements to offer. So what I will do? I will simply copy the elements from A of I into C of K. Move K forward, move I forward. Okay. I write another while loop. Ki boss, maybe array B can be pending. So while j is less than n, okay, C of K is equal to B of j. I copy the elements, okay, into C of K, do a K plus plus, do a J plus plus. And what I tell you guys is, once you come outside this while loop now, either I will have become equal to M or J will have become equal to N. That is, one of the arrays would have terminated. So out of these two while loops now, only one of the while loops will run and copy the remaining elements of the array which is pending into array C. Okay. Let me write the code on online GDB, then it will make more sense, right? And then we can have an analysis of the code as well. Just let's go to the online GDB and then it will become more clear, right? So let's say I want to write a merge function, right? So let's say I just want to write a merge function, right? अभी ऐसे ही कर देते हैं, ठीक है? Function नहीं बना रहा हूँ, अभी ऐसे ही लिख दे रहा हूँ. Okay. So let's say that you have two sorted arrays, right? Let's say you have an array A. Okay. It is sorted. Let's take elements 1, 7, 8, 15, and let's say 20, 35. Okay. So array A is sorted, and let's say array B ले लेते हैं. Okay. So let's say this is containing of, 6, 8, 15, let's say 25, let's say 45, 50. Okay, like this. Okay. So array A and B are individually sorted. So what do I do? First of all, let us make, okay, let's write int m is equal to a dot length. This is the size of array A, and int n is equal to b dot length. Okay. Now what do I do? I first of all make an array C. Okay. So array C is a new int. And how many elements it will contain? It will contain m plus n elements. Now what do I do? Let us make pointers, right? Int I is equal to 0. It is at for array A. Int j is equal to 0. This is for array B. And int k is equal to 0. This is for array C. Okay. So I, j, and k are pointing to the starting indexes of array A, B, and C. Okay. Now what do I do? While I is less than m and j is less than n. इसका मतलब क्या हुआ? While both the index I and j are pointing at valid indexes, right? I less than m matlab I is at a valid index. J less than n matlab j is at a valid index of array B. So while both the indexes, both the pointers are at valid indexes, what does it mean? It means both the arrays have element to offer. So let us compare. If A of I is less than B of j, okay? If A of I is less than B of j, so what will I do? I will take the elements. Achha, let's do a less than equal to, right? You can, inequality, I can prefer any one of the array. Okay. So if A of I is less than or equal to B of j, I will take the elements from array A. So what do I do? C of k, is equal to A of I. Okay. Write the element from A of I into C of k. Do a k plus plus and do a I plus plus. This is the operation that we are performing, right? And there should be a else also. Ki boss, if B of j is less than A of I, so what should I do? I should take the element from array B. So C of k is equal to B of j, and then I will do a k plus plus and I will do a j plus plus. Okay. This is what we are doing. So this while loop, this entire while loop will keep on running when till both the arrays have elements to offer. So I think everyone will agree, you will come outside this while loop when either the value of I becomes equal to m or the value of j becomes equal to n. When either of these conditions become false, you come outside the while loop. That means when you are outside, this means one of the arrays have finished. You have taken up all the elements from one of the arrays. That is why you came outside this while loop, right? Now what do I say? I don't know which of the arrays has finished. So let us do something like this. I say while I is less than m. And when will this loop run? This loop will run if array A has pending elements. Okay. So if array has pending elements, this loop will run. And what do? I simply copy the elements into array C. So C of k is equal to A of I. And what do? K plus plus and I do a I plus plus. Okay. So just copy the elements from array A. But I don't know whether A was pending or B was pending, right? So for safety, I'm writing one more loop while j is less than n. Okay. Ki boss, in case array B was pending, then the first loop will not run. See, if array B had elements now, then array A is exhausted. So the value of I will become equal to m. So this loop will not run and this loop will run. So out of these two while loops, only one of the while loop will run because only one of the arrays has pending elements. Okay. So if array B has pending elements, I will run this while loop. And what do? C of k is equal to B of j. Okay. And let's do a k plus plus and do a j plus plus. Job done. So either one of these two while loops will run and it will copy the remaining elements of the array which is pending into array C. And after this, my job is done. So just to make you guys understand, let us print the array C. Let us just convert it into string and print, makes it easier. Okay. Let's print array C. And for this, we also need to, import java.util.star. Okay. So let's try to run it and see. See, 1, 6, 7, 8, 8, 15, 15, 25, 35, 45, 50. So array C is consisting of all the elements of A and B in sorted order. Okay. So this entire process that I talked about just now, it is known as merging. Okay. You are merging two sorted arrays into a third array C. Okay. Now tell me guys, how many of you are clear with this process? कितने लोगों को समझ में आया what we are doing? Yes. Okay, cool. So I think everyone is clear here. Explain from 37. What is 37? See, when do you come outside the while loop? Right. When do you come outside this while loop? Separate. What if we don't? Just give 1 sec, guys. There are so many questions. It becomes very difficult to take them. See, I'll just try to explain it once again, right? See, what is this loop doing? I less than m means I is at a valid index of array A. Okay. And j less than n means j is at a valid index of array B. Okay. So if both these conditions are true, that means both the elements have elements to offer. Both the arrays have element to offer. So do a comparison. If A of I is less than equal to B of j, that is, the element that array A is offering is lesser than or equal to the element that array B is offering. So take the element from array A and write it in array C. So I will say C of k is equal to A of I. And then I move my k pointer forward to the next location in array C and I move I plus plus. Now, when will I come into this else block? If the element offered by array B is smaller. So in that case, what I will do? I will pick up the element from array B, write it in array C, then do a k plus plus and do a j plus plus. Why do I do a k plus plus? Because I want to move to the next location in array C. And why do I want to do a j plus plus? Because I have picked an element from array B and now I want to see what is the next element that array B has to offer. So when will we come outside this while loop? We will come outside this while loop when either the value of I becomes equal to m, which is the size of array A, or j becomes equal to n. What is the physical meaning of these, right? If I becomes equal to m, इसका मतलब क्या हुआ? Array A का valid index was from 0 till m minus 1. And if I has become equal to m, that means array A has been finished. So basically, we will be coming outside this while loop when either one of the arrays has terminated. सारे elements उठा लिए. Okay. So you come outside. Now I know that one of the arrays has been finished when I come outside this while loop. So what do I say? I don't know which array has finished, right? So I just write two while loops, right? So let's assume that array A has terminated. So I ka value is become equal to m. Yes. If array A has terminated, then I is equal to m. And j is still at a valid index of array B. Okay. So what I will say? First I do, while I is less than m, will this loop run? No, this loop will not run. If the value of I is equal to m now, m is less than m, that is false. So this loop will not run. Okay. Then I come, while j less than n, yes, j is at a valid index because array B is pending. So I will take the elements from array B, write it in array C and move forward. Okay. So I am telling either one of these two while loops will be running. Okay. ये दोनों while loop कभी नहीं चलेगा. Either one of these while loops will run because one of the arrays definitely has been terminated outside this while loop. Okay. Okay. Let's quickly do a poll. I think that should help us to understand, right? See, because it is a very, very important concept and the merge sort will be based on this, right? So can you guys just quickly cast a poll if you are clear? Then I'll go to an advanced step of this, like just an extension of this, right? Anybody, please help me to understand. Where are we standing? Okay, cool. So I think most of the folks are clear here, right? We have greater than 90% folks are clear, right? So now I'll ask you one question. Okay, I'll ask you one question, right? So what is the time complexity of this merging? Let's look at the code, right? What is the time complexity of this merging? Can anybody help me with the time complexity? Can anybody help me with the time complexity? Logically socho, right? What are you doing? You are doing comparison right, comparison right, comparison right, comparison right, comparison right. Then copy. So can I say, what is the total number of write operations that you are doing in array C? See guys, how many total write operations are you performing in array C? Here you will perform some operations, and outside this while loop also you will be performing some operations. So can I say you are in total, you are writing to array C m plus n times, right? What am I doing? Dekho na. Compare elements, write. Compare, write. Compare, write. Compare, write. Compare, write. And then when one of the arrays is finished, you just iterate over the remaining part of the array and do write. So in total, you are iterating over the array C and writing elements. How many elements? M plus n elements. So in total, there are M plus n operations. So the time complexity of this merging will be big O of M plus n, where M is the number of elements in array A, n is the number of elements in array B. And this makes sense, right? Because the total number of operations, okay, मैं क्या कर रहा हूँ? See guys, try to understand. Let's take a very simple case, right? If I have 1, 2, 3, and let's say you have थोड़ा गड़बड़ हो गया 1, 4, 9, okay, and you have 2, 3, 12, 2, 3, 12, right? Something like this. So what am I doing? See how many operations am I doing? I compare 1 with 2, write 1, move forward. I compare 4 with 2, write 2, move forward. Okay, sorry, move forward. I compare 3 with 4, write 3, move forward. I compare 4 with 12, write 4, move forward. I compare 9 with 12, write 9, move forward. One of the arrays is finished, and then you will just copy the remaining elements that are present in the second array, right? So I will write 12, I will write 18, I will write 19. So how many write operations are you doing on this array? M plus n write operations, right? So it is basically a big O of M plus n time complexity. You are merging M plus n elements. That is why it is big O of M plus n time complexity. And what is the space complexity? The space complexity is also big O of M plus n because we have used an additional array C to perform the merging. Okay? Cool, guys. So we'll just close this poll. It's almost everyone are clear here, right? So I'll just close the poll. 73 and 20, it's almost 95% folks. Okay. So now let me extend, right? Let me extend this question a little further, right? Now that we are clear with how to merge two sorted arrays, let me try to extend this question a little further. Okay. And this is the more important part, right? Major important part. Ye samajh gaye na? So my job will become very, very simple. So my aim will be to try to, help you guys understand it in the most simplest manner possible. Okay. Why is this happening? Just one sec. Yes, guys. So let's come back, right? Now, what were we doing till now? We had two separate sorted arrays. But now I ask you one thing. I give you a situation like this. Ki boss, you have an array. Okay, you have an array. Dhyan se dekhna, you have an array, right? It is a very big array, right? I don't care, right? It is a very big array. Okay. Aisa imagine karo, this is a very big array and I am just showing you a part of the array. Okay. Let's assume that some part of the array looks like this. 2, 5, 8, 12. Okay. 3, 6, 7, 10. Okay. This is a very big array, right? I have not drawn the entire array. Just think that this is a very, very big array. Okay. And inside this array, you have a part that looks like this. Okay. Then can I tell you, boss, let's assume that this is index L. This is not index 0, guys, mind you. This is not index 0. This is some random index in the array. Let us call it at index L. Okay. Can I tell you, boss, from index L till index mid is a sorted part of the array. And from index number mid plus 1 till index number R is another sorted part of the array. See, this time you don't have two separate sorted arrays. What I want you guys to understand is you might get a situation like this wherein you have a very big array. Okay. And inside this big array, you are able to figure out that, boss, you have certain indexes. Let's say from index number L, this is any random index, right? I don't know the number. That is why I've taken variables, right? From index number L, from index L till index mid. Okay. From index L till index mid, you have a sorted array. See, sorted part of an array 2, 5, 8, 12. And from index number mid plus 1 till index number R, if you look 3, 6, 7, 10, this is another part of the, this is another sorted array or another sorted part of the array. Okay. So this time, instead of having two different sorted arrays, I have two sorted arrays in the same big array, two sorted subparts. Think of it like this. Now I ask you, boss, can you merge these two sorted parts? Can you perform a merging of these two sorted parts such that from index L to index R is sorted? Guys, try to understand. In this array, from index number L till mid is a sorted part. From index number mid plus 1 till R is a sorted part. Now, what I am telling, can you perform a merging of these two sorted parts, right? One is from L till mid and the other part is from mid plus 1 till R. Can you perform a merging of these two parts in such a way that from index L till index R of the main array is sorted. Is the question making sense, guys? I have enabled chats. Is this the question making sense? What I'm trying to ask? From index L till index mid of an array is sorted. Okay. And from index mid plus 1 till R is another sorted sequence. Right. What I want you guys to do is, I want you guys to perform a merging of these two sorted subparts. Okay. Bhai, kuch nahi karna hai. Same question, repeating. See, in the earlier case, we had two sorted arrays, different arrays. This time I am telling you, think that this is a very big array. It is a very big array. Okay. And I am telling you, from index number L till index number mid is a sorted subpart. Dekh lo, 2, 5, 8, 12 is a sorted subpart. And from index number mid plus 1 till R is another sorted subpart. So this time, instead of having two separate sorted arrays, you have two sorted subparts of the same array. And what I am asking you, I want you guys to do some logic such that after performing a merging from index number L till index number R of my main array, right? This is a big array. Okay, let's call that this is array A. So from index number L till index number R of my array A becomes sorted. That is, I want the contents like this: 2, 3, 5, 6, 7, 8, 10, 12. This is the picture that this is our current state or the starting state, and this is where I want to reach at. From L to mid is sorted, from mid plus 1 till R is sorted, and I want that from index L till index R, the entire array becomes sorted. From index L till R. Is the question making sense first of all? Kya question हमें समझ आ रहा है? What I want you guys to do? Yes? Question is clear? Assume karo you know these indexes, right? If you don't know these indexes, you won't be able to do. Assume you know these indexes. Abhi ke liye maan lo magic, you know the indexes, right? So what should I do? Right? What should I do? Okay. So I will tell you two ways. Right? And whatever you understand, that is fine for me, right? So let us come, right? So मैं क्या बोल रहा हूँ? Let's have a. This is our original array. I am writing the elements once again. 2, 5, 8, 12, 3, 6, 7, 10. Okay. Now let's say this is index L. This is index number mid. Okay. And this is index number R. Okay. And see, this is a very big array, right? I don't know, right? L might be 0, might not be 0. Not necessarily. This is a random index, right? This can be a very big array. Okay. And let's say that the size of the original array is n, right? N size is the original array. And let us call this array as A. This is the original array A. And the size of this array is n. Okay. Now, what do I do? मैं बोलता हूँ, boss, look at the algorithm. I say make a temporary array, make a new temporary array. I am telling you two different ways of doing this. Whatever you feel more comfortable, you can understand via that. Okay. I say let us make a temporary array of the same size as array A. Okay. So what I will say, boss, मैं थोड़ा mapping कर रहा हूँ ऐसे, हाँ. So it will be easier for you guys to understand. I say make a new array temp. Okay. Make a new array temp of size n, which is the size of the original array. So make a new array temp, which is the size of the original array n. Now tell me, guys, when I make an array temp of the same size as the original array, definitely it will also have index L, mid, and R. Does everyone agree? Boss, you have made an array of size n. So definitely it will contain index L, mid, and R, na, for sure. करना ही पड़ेगा, boss, है ना? Now what do I tell? I will perform a merging of these two sorted subparts into this space which I have drawn, highlighted, right? So what was the logic that we had taken? We had a pointer I at the starting of my first array. Okay. So where will I be? What is the starting of this first subpart, sorted subpart? I will be equal to L. Does everyone agree? I will be at the index L. सोच के बताना, guys. What were we doing with I? I is basically at the index of the, first sorted array. So this is my first sorted part. So I will be at index L. Similarly, where will J be? Can anybody tell me what should I initialize J with? I plus 1. सोच के बताओ, guys. Where should I initialize J with? Mid plus 1. Correct. So J will be at index mid plus 1, which is the starting index of the second sorted subpart. Now what I will do? I had another pointer K. Where do I initialize K? Again, I will initialize K at L only because I want to merge these two sorted subparts in this range of temp. From index L to R of temp, I will be using and I will be, merging them here. Okay. So now what should my condition be like? What should my, while I and J are valid indexes, okay, while I and J are valid indexes, I will do a comparison. So can you guys help me with the code? I'm writing the code smallly here. While, can I say boss, while I is less than equal to mid, is this the valid range for index I? For I, देखो ना, what is the valid indexes for the left subpart from index L till index mid? So while I is less than equal to mid, that means I is pointing to a valid index of the left sorted subpart. Okay, and J is less than equal to R. That means J is also pointing at a valid index of the right subpart. So what I will do? I will compare. What I will compare? I compare A of I with what? A of J. Boss, this time you don't have two separate arrays. You have the same array. You have the same array, right? So if A of I is less than equal to B of J, oh sorry, देखो मैंने ही गलती कर दिया. If A of I is less than equal to A of J, you have the same array, right? So what I will do? If A of I is less than equal to A of J, so this is smaller. So what I will do? I will take the array. I will take the element from the left subpart. So what do I do, guys? Temp of K is equal to A of I. सही है? So I will take this 2 and write it here at this index. Okay. And where is K? This was at index L of this. Okay. And then what I will do? I will do a K plus plus. I will do a I plus plus. ठीक है? मैं पूरा कोड नहीं लिख रहा हूँ. Let us try to understand the logic, right? Then I do a K plus plus. K comes here. And I do I plus plus. I comes here. Again, I will compare. I and J are valid indexes. So I will compare 5 with 3. 3 is smaller. So I will take A of J, write it here, do a K plus plus and do a J plus plus. Then what I will do? I compare A of I with A of J. Both are valid indexes now. So 5 is less than 6. Write 5 here. Do a K plus plus. Do a I plus plus. Okay. Both I and J are valid indexes, right? Yes. So I compare 8 with 6. 6 is lesser. So takes this B of A of J, right? Write it here. Do a K plus plus and do a J plus plus. Again, I and J are valid indexes. So I compare 8 with 7. 7 is lesser. Write 7 here. Move K forward. Move J forward. Okay. Again, both I and J are valid indexes. What should I do? 8 is lesser than 10. So I write 8 here. Move K forward. Move I forward. I comes here. Okay. I and J are valid indexes. I compare 12 with 10. What happens? 10 is smaller. So what I will do? I will write 10 here. Do a K plus plus, do a J plus plus. Now, the moment you do a J plus plus, you see that J goes outside the valid index of the right subpart. So what do? I come outside this while loop and then I will have 2 while loops. What are the 2 while loops? I will check. Is the left part pending? How? While I is less than equal to mid. If the left part is pending, I will just copy the elements from A, from this left part, right, into K. So while I is less than equal to mid, this part will run. What do? I do temp of K is equal to A of I. So I write 12 here. I do a K plus plus and I do a I plus plus. Now, the moment you do a I plus plus this time, what will happen? This while loop will terminate. That means you have copied the remaining elements from the left subpart into the temporary array. Done. Then you will have another loop while J less than equal to R. But that loop will not even run because when you came outside this while loop, now at that time only this right subpart was exhausted. Right? So now, have we merged the 2 sorted subparts into the temporary array from index L till index R? Yes. Now inside the temp array from index L till index R is a sorted sequence. Now what was my end goal, guys? My end goal was कि boss, in my original array A only, from L to R becomes sorted. So what I will do? I will iterate over this temporary array. So I will write a loop for, let's say int Z is equal to L. I will start from index L and go all the way till index R. Okay. So I will iterate over this array temp. And you know what I will do? A of Z is equal to temp of Z. So I will copy the elements. The boss, I iterate, I come to index L. I copy the element from here into array A, index L. I come to here, copy the element from here back into array A. So do you agree what will happen? Inside array A, all the elements from index L till index R will be sorted. Do you guys understand this part, what I'm trying to say? I'll write the code, it will become more clear. But how will we identify? Forget that thing, right? Just focus on the merging part at this point of time. Just focus on the merging part at this point of time. So I'll repeat it once again. No, it cannot be done without creating the temporary array. I will repeat, right? Let me repeat once again. Okay. So what I'm trying to say, see, let's say you have an array A, okay? And see, I am just drawing a smaller subpart, right? It is a very big array A, okay? And let's say you identify, somehow you identify. How you identify, I don't care at this point of time. Socho ki magic hai, right? I identify that, boss, in my bigger array, I have two sorted subparts. I see two sorted subparts, right? You know, two sorted subparts. So I say from index L till index mid is a sorted subpart. Forget how are you getting these indexes at this point of time. And from index mid plus 1 till index R is another sorted subpart, right? And the array is very big, right? I don't care about the full array at this point of time. It is a very big, right? But I know that from index L to mid is a sorted subpart, and from index mid plus 1 till R is individually sorted in itself. These two are individually sorted subparts. And my end goal is to sort this array A from index L till index R to get this entire range sorted. Okay. So what do? I tell boss, you have two sorted subarrays, right? You have two sorted subparts. So first of all, I will create a new temporary array of the same size as the original array. So I create a very big temporary array of size n. Okay. And that temporary array will also have indexes from L to R for sure, right? Because L and R are lying between 0 and n minus 1. So I make a temporary array of size n. So it will have, indexes from L to R. Now what do? I treat it as my first array. I treat this as my second array. And I want to merge these two sorted arrays inside this part of the temporary array. So what do? I को मैं कहाँ initialize करता था? In the algorithm, I initialized I at the starting index of the first array. So I will be equal to L. This is the starting index of the first array. J will be the starting index of the second sorted subarray. So J is equal to mid plus 1. Okay. And where was K? K was at the starting index of the third array or the array C, right? So I will say K is equal to L. So I want to start filling in this range. Now what do? While I is less than equal to mid. So while I is at a valid index of the left part and J is less than equal to R, that means J is at a valid index of the right subpart. What I will do? I compare A of I with A of J. Okay, I'm just comparing. 2 is less than 3. So I write 2 here. I do a K plus plus and I do a I plus plus. Again, I and J are both valid indexes. Okay. See, I should be less than or equal to mid for it to be a valid index of the left part. And J should be less than equal to R for it to be a valid index of the right part. Okay. So I see boss, 5 is, both are valid indexes. 3 is less than 5, write 3 here. Do a K plus plus, do a J plus plus. Same algorithm, right? Again, compare. If this is lesser, so I will write 5 here, do a K plus plus, do a I plus plus. I compare 8 with 6. Okay, 6 is lesser. Write 6 here, do a K plus plus, do a J plus plus. I compare 7 with 8. 7 is lesser. Write 7 here, do a K plus plus, do a J plus plus. Okay. Now J comes at index R. This is the last valid index, right? I compare 8 with 10. 8 is lesser. I write 8 here, do a K plus plus, and I do a I plus plus. Okay. I and J are both valid index till now. I compare 10 with 12. 10 is lesser. I write 10 here, do a K plus plus and do a J plus plus. The moment you do a J plus plus, now J will go outside the valid index range of the right subpart. So what do I say? Now you just have one part of the array remaining, right? I don't know which part. So just write two while loops once again. While I is less than equal to mid. While I is less than equal to mid means the left part of the array is containing more elements. So if this part is pending, that while loop will run and you will copy the elements. Okay. So C of K or temp of K is equal to A of I and I do I plus plus. The moment I comes here, that while loop will terminate. Now I check, was the right part pending? While J is less than equal to R, but J is already greater than R. So that will not run. So I know that now index number L to R, index number L to R in the temporary array is sorted. But I wanted, boss, index number L to R of my main array to be sorted. So what I will do, I will just copy the elements from temp back into the original array. So I run a loop from index L to R and I copy the elements from temp into array A. So after this copying, right? After this copying from index number L to R, from index L to R of my main array, okay, index number L to R of my main array will now become sorted. Is this part making sense? I have tried to, go very slowly here. This is the first approach, right? Does everyone agree? So if I write a magical function, right, merge, if I say merge, okay, I pass this array ARR, original array, okay, and I say boss, L mid and R. I know L mid and R. Then can you expect that after this magical function that I have told you, from index number L to R of ARR will become sorted? Do you agree? See, when I call the merge function ARR L mid R, I assume that boss inside array ARR, from L to mid is a sorted subpart, from mid plus 1 till R is a sorted subpart. And can I assume that when this function runs using this logic, I can assume that from index L to R of my main array will get sorted? Do you agree? Yes, do you agree? Okay, so let us write this merge function, right? Let us write this merge function. Can we calculate mid if we are given L and R? No. At this point of time, what I am saying, assume that you know what are the contents. Okay, sir, can't we create temporary of size R minus L instead of N? That's a good question, Pranchu. I'll come to that, right? That is the second, optimization that we talk about. But is this logic clear to everyone, what I have discussed? Yes? Is this logic clear, what I have discussed? यहाँ तक समझ आ रहे हैं? So let us try to first code up the merge function. ठीक है? पहले मैं merge function code करता हूँ. ठीक है? Let's go to online GDB. See, I will discuss one implementation of merge. Then we will go to Mergesort and try to understand Mergesort entirely, do the time and space complexity analysis, and then I will give you a better merge function, right? So तुम लोग देख रहे होंगे, boss, what is one drawback? I am making an array of size n every time. Temp array ka size is n. But at the end of the day, the area of interest is just this one, right? But ठीक है, we will optimize this later. Okay, so let's come here. इधर ही लिख दूं क्या? नहीं, अलग से लिखता हूँ. See, the more you are clear with the merge function, the better you will understand Mergesort. That is my guarantee. ठीक है? तो अपने ये basic merge function लिखते हैं. I'll write a new function, right? So public static void. What should be the return type? Yeah, it should be void, right? Okay. Now let's write the name merge. Now it will take the reference of my array. Okay, this array ARR. Okay. I'll give it the array. This is the original array. And I say, boss, I pass these indexes L, mid, and R. Okay. Okay. So iska matlab kya hua, guys? I will write here for your understanding that from index number L till index number mid is the left sorted subpart. This is a sorted subpart in itself. And from index number mid plus 1 till R is the right sorted subpart. These two are two sorted subparts I have assumed, right? और मेरे को क्या करना है? What is the end goal of the merge function? The end goal of the merge function is, end goal is that from index L till index R, from this entire index L till index R, the array ARR contains sorted sequence. That is my end goal. Okay, this is my end goal. So now what do I do? First of all, what do? We make a temporary array, right? Just writing code for the algorithm just discussed, right? I make a temporary array, and what should be the size of this temporary array? Can anybody help me? What should be the size of this temporary array? Can anybody help me? Anyone? किसका कितना? अभी के लिए जो लॉजिक समझे हम लोग. Can I say the size of the temporary array should be the same as the size of array ARR? देखो ना बॉस, क्या किया था? The size of the temporary array is equal to the size of the original array, right? So I will say it's nothing but ARR dot length. Okay. Made this temporary array. Now what I will do? Let's run our basic merge logic, right? So int I, where will I point, guys? The starting index of the first array, okay, which is the left part. So int I is equal to L, okay. Where will j point? J will point to the starting index of the second array, that is the right part. And what is the starting index of the right part? Mid plus 1. So j will be mid plus 1. And where will be k? K will be at the index where you want to write, okay. So I want to merge in index number L to R of my temp array. Okay, I will be using indexes L to R of the temp array to perform the merging. So where will be K? K will be at index number L. Okay. Now I write my logic. While I will see that I and J both should be at valid indexes. So what do I see? While I is less than equal to mid, that means I is at a valid index of the left part, and J is less than equal to R. That means J is also at a valid index. That means both the left and the right parts have something to offer. So what do I see? If ARR of I is less than equal to ARR of J, I compare both these elements. Okay. If ARR of I is less than equal to ARR of J, then what do? I take the element from the left part. So what do? Temp of K is equal to ARR of I. Then I move K forward and then I move I forward. Okay. Otherwise, in the else part, what I will do? In the else part, I say temp of K is nothing but A of or ARR of J. Then I will move J forward and I will move K forward. Okay. So I am basically filling, or I am basically merging these two sorted subparts into the temp array from index L till R. I am using indexes L till R of the temporary array to perform this merging. Now, once I come outside this while loop, I know that either the left part has finished or the right part has finished. So what will I do? I don't know which part has finished. So write a loop for both the parts. While I is less than equal to mid, what will I do? Copy the elements. So temp of K is equal to ARR of I. And then what should I do? K plus plus, and I should do I plus plus. Okay. Then done the part for the left part. Let us also write for the right part. I don't know which one would have been finished and which one would have been not. So while J is less than equal to R. Acha guys, you can also see code written like this, just so that you are aware. Temp of K plus plus is equal to ARR of J plus plus. What does it do? These three lines and this one line do the same job, right? Temp of K plus plus is equal to ARR of J plus plus is nothing but, first of all, temp of K equal to ARR of J hoga, and then both the values of K and J will get incremental. Okay, same thing. Okay. Now, once we are done with this, I now know after this, can I say, boss, index number L to R of temp array contains the sorted merge. Do you agree? Index number L to R of the temp array will now contain the merging of the two sorted arrays in sorted fashion. But what was my end goal? My end goal was that index L to R of array ARR should contain the entire sorted sequence. So what will I do? I copy the elements from temp back into ARR. So jo element, see the element that is present at index number L of temp, right? That should be present at index number L of ARR. The element that is present in index number R of temp, that should be present in index number R of ARR. So what do? I just run a loop, right? For int Z is equal to, I start running from L and I go all the way till R. Okay? Z plus plus. And what do? See, I am at index number L. So I take the element which is present at index number L of temp and I write it to ARR. So I will say ARR of Z is nothing but temp of Z. So when I run this loop, you will see that all the elements from index L to R of temp gets copied to index L to R of my array ARR. So after this for loop, I can say that, boss, now index number L to R of ARR is sorted. Yes, done. Now, first of all, let's go to a poll, because if you understand this, I'll go to merge sort, right? I'll discuss the second merge technique a little bit later. Let's see how many folks are almost clear or on the verge of clarity, right? So guys, just let me know how many of you are clear with this merge function, right? I'll just start the poll. You have understood the end goal, the left part, the right part, and everything, right? Tell me how many of you are clear with what we are trying to do. We are 450 plus people, so I want at least 250 plus to go and cast a vote, right? See, if everyone casts the votes, it becomes easy for me to understand the demography of the class, right? So, alas mat khao, just go and just click on a button. It's as simple as that, right? If you guys want, we can be done with the poll in 1 minute, right? So, we'll just request everyone to quickly cast a vote so that I get an idea of what is going on, right? Okay, so we have 80-20 ratio. Okay, cool. I think I'll just repeat it once again for folks who are not clear, right? ठीक है, मैं एक बार फिर से बोलता हूँ हो क्या रहा है, ठीक है? See, if you understand this step now, you will be clear with merge sort. इतना मेरा guarantee है. So the most important part for us is to understand this, process, ठीक है? And I'll do a dry run of the code, right? Doing a dry run will help almost everyone, right? And guys, but I am not happy with you all, right? Not that you are not understanding, but people are very lazy, right? And you don't go and vote. So I'm not very happy, right? So that is a disappointment. But anyways, let's come back. ठीक है, चलो अभी देखते हैं कि एक फंक्शन कर क्या रहा है, ठीक है? So let us try to understand, right? I am just telling you what does the merge function expect, ठीक है? So let's say you have a part of the array ARR, ठीक है? You get ARR array, ठीक है? And let's say it is a very big array, okay? It is a very big array. I see, I don't care about all these elements, right? All these front and the back parts, ठीक है? And I pass L, mid and R. So let's say previous example ही ले लेते हैं, या छोड़ो मैं खुद बना लेता हूँ अभी. 8, 10, 15, 2. Okay, so let's say I call merge ARR. I call the function, right? I call the function like this, merge, okay, ARR, and I say, boss, let's say this is index number L, which I say somehow ki let's say this is index number 5. Assume कर लो, मेरे को नहीं पता कैसे. This is index number 7 and this is index number 8, 9, 10, 11, right? This is index number 11. Okay, so I am telling you, boss, merge ARR 5, 7, 11. That means from index number 5 to 7 is a sorted subpart. From index number 8 till 11 is a sorted subpart. Okay, and I want that, boss, after this merge function, the entire array ARR from index number 5 till index number 11 should be sorted. ये पूरा जो part है ना, ये sorted होना चाहिए. At this point, if you see 8, 10, 15, 2, 5, 50, 100, from L to R is not sorted, right? From L to mid is a sorted part, and from mid plus 1 till R is a sorted part. So what do? I say make a new array. Make a new array. मैं बोलता हूँ make a new array. Okay, make a new temporary array, and that will be very big. Okay, of the size n. Okay, let's say this array is of size 100, right? So you make an array of size 100 itself. Okay, the temporary array is the same size of the original array. So definitely my temporary array will have these indexes for sure. From index number 5 till index number 11. These will be present in my temporary array. So now what do? I will be merging these two sorted subparts in index number 5 to 11 of my temporary array. Okay, so what do? See, where did our pointer I go? I goes to the starting of the first subarray. So I is at index number L. So I is at index number 5. And where is J? J will be at index number 8, which is the starting of the right part. And what do I say? While I is less than equal to mid, that is while I is less than equal to 7, that means I is at a valid index. And while J is less than equal to 11, that means J is also at a valid index. So both the left and the right subparts have something to offer. And K will also be at index 5 here at L. So what do? I compare 2 with 8. 2 is lesser. So I say temp of K is equal to 2. So I write 2 here, move K forward, move J forward. Again, I and their valid index, I compare. I write 5 here, move K forward, move J forward. Okay. I compare 50 with 8. 8 is smaller. I write 8 here, move K forward, move I forward. Okay. Again, both are valid indexes. I compare, write 10 here, move K forward, move I forward. Again, both are valid indexes, right? Compare 15 is lesser, write 15 here, move K forward, move J forward. Sorry, move I forward. Now, when I move I forward, you will see that I has become greater than mid. So the while loop will terminate. And now you have just one subpart, to take care of. So you look at your while I is less than equal to mid, you run another loop, right? You run another loop for that. But that will not run because the left part has been exhausted. Then you run another loop. While J is less than equal to R. Ki boss, while J is less than 11. Yes, J is less than 11. So I will copy. Okay. So temp of K is equal to A of ARR of J, write 50 here. Do a K plus plus, do a J plus plus. Copy element here, do a K plus plus, do a J plus plus. So it is finished now. Now you will see from index number 5, sorry extra ban gaya hoga, from index 5 till index 11 of the array temp is now sorted. Dekho, from index 5 to 11 of temp is sorted. But what I wanted ki from index 5 to 11 of my array ARR to become sorted. So what I will do, I come to index number 5 and I say, boss, ARR of 5 is nothing but temp of 5. Okay. So I will write here 2. Then I come to index 6 and I copy this 5 here. Okay. I come to 8, I copy this 8 here. I come to this index where 10 is stored, I copy this here. Okay. I come to this index, I copy 50 here. I come to this index, I copy 10 here. I write 10 here, let's say. I come to this index, the last index, here it is 100, I write 100 here. Okay. So I have copied all the elements from index L to R of temp into index L to R of ARR. And now I can say that boss from index L to R of ARR is now a sorted sequence in itself. Is it anyways helping you guys to understand better? Yes. Are we clear? Yes. Got it. Line number 49 alter में आपने बताया है वो समझ नहीं आया. Line, what is line number 45? Let me have a look. Line 45. Line 45 is nothing. Same thing we are doing now. अरे ये नहीं समझ में आया, छोड़ दो इसको. नहीं समझ में आया तो कोई दिक्कत नहीं है. Forget it. Just do like this, right? Anyway you are comfortable with. Okay. ठीक है. Now, so I think we are here, right? Yeah, let's try to run it and see, show the output that I'll do. हाँ, code से ही बताया ना? Code से ही तो do. Let's have a look at the code, right? I think after that I have to move on. Okay. So see, nothing we are doing. From L to mid is sorted, from mid plus 1 to R is sorted, right? So first of all, I create a new array temp of ARR.length size. I, J and K को initialize किया. Then till both the left and the right subparts have element to offer, you compare and you write it in array temp. And we are using indexes from L to R of temp only. Okay. Then once you have written down everything, what do? I copy the elements back from temp into ARR. So what do? Z is equal to L, Z less than equal to R. So I iterate from index L till R and I just copy the elements from temp. So temp of L will become equal to ARR of L. जो भी temp of L plus 1 में रहेगा, that will be copied to index L plus 1 of ARR. So now from index L to R of ARR, that will become sorted. Okay. Let us try to just test whether it is working fine to make sure. ठीक है. तो मैं एक array बनाता हूँ ऐसे ही for your understanding. ठीक है. So let's say random elements. I don't care here. ठीक है. Now let's say you have a sorted left part 4, 5, 10. Okay. And you have a right part, right? Let's say a right part will be 2, 6, 7, 8. Okay. And then you have random elements. I don't care. Okay. So try to understand, guys. 4, 5, 10. This is the sorted left part. And 2, 6, 7, 8. This is the sorted right part. So what I will do, I will say merge, just giving an idea of how it works. ARR, comma. What is the starting index of the left part? Index number 4, if I am correct. 0, 1, 2, 3, 4. Right. Index number 4. What is the ending of the left subpart? 5, 6. Index number 6. What is the starting of the right subpart or ending of the right subpart? This, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if I'm correct, it's 10. Okay. So now what will happen? See, guys, from index number 4 to 6 is a sorted part, right? 4, 5 is a sorted part. And from index number 7 to 10 is a sorted subpart. So now when I call this merge function, I will expect that from index number 4 till index number 10 of ARR becomes sorted. Let us try to print and see. Let us do arrays dot to string ARR. We'll try to print it, import java dot util dot star. So what I am thinking should be the output. मैं एक बार output बना लेता हूँ. ठीक है. So the first 3 indexes will be undisturbed, right? So 1, 5, 10, 8. These will be undisturbed, right? Now see, guys, this is the area of interest, right? This part. So I should get the output here as 2, 4, 5, 6, 7, 8, 10. So 2, 4, 5, 6, 7, 8, 10. This should be sorted. And here you should have 199 as it is. 199 as it is. This should be the output that I am expecting. Let's try to run it and see. Oh, sorry. Let's see, 1, 5, 10. Yes, 8 is also there. Then 2, 4, 5, 6, 7, 8, 10. 2, 4, 5, 6, 7, 8, 10. See, from index L till R, from index 4 till 10 of my array ARR now has become sorted. Okay, cool. So I am pretty clear that most of you folks should now be in a better position, right? And it's almost a 51 to 26. Okay, okay. So guys, I would expect all of you to do a dry run, right? And try to see. Is everyone clear with this? I'll just ask one more time so that we can move further. Yes, cool. Okay. Agar sabko clear hai, then it's fine. We can move further. Okay. So now you understand the magical merge function. We have written the logic of the merge function. Okay. Now, try to do a dry run, guys, also yourself, right? You will understand what is happening. Now let us come to the major topic. Okay. I don't think I'll be able to explain the second type of merge today, but yeah, I'll give you a homework, right? Reading from Geek for Geeks, right? So you can figure out, right? Okay. Now let us come to the concept of merge sort. So guys, understand one thing. I have developed the tool merge, pass it ARR, pass it L, pass it mid, pass it R. Okay. If I call this merge function, my assumption is from index L to mid is a sorted part. From index mid plus 1 till R is a sorted part. And when you call this merge function, from index L to R of ARR will become sorted. Does everyone agree? I have developed this magical function. If these two assumptions hold true, then you will get this part entire as sorted. यहाँ ये मेरे को पता है कैसे करते हैं, ठीक है? Now let us come to the crux of merge sort. Okay. Now let's get started. Right? So what does merge sort say, right? Merge sort is basically a recursive algorithm. It's a recursive algorithm, right? So let us take an array and see how merge sort actually functions. How much time we have? Okay, we have 30 minutes. Good enough to understand merge sort. अगर वो merging clear हो गया ना तो merge sort मेरे लिए simple हो जाएगा. Let's see. Now I will understand how many of you are clear actually with merging. Okay. So let us say you have this array 8, 2, 9, 6. This is a whole array, right? 8, 2, 9, 6, 5, 3, 7, 4. This is the array. And I want to sort this array ARR. So I ask you, hey, can you please sort this array for me? Now, what do I tell you? Now, guys, try to understand. This is this entire array, right? From index 0 till index 1, 2, 3, 4, 5, 6, 7. Okay. So this is an array of size 8. And I ask you, hey, can you please sort this array for me? So you come and tell me, hey, Adarsh, you know what? Sorting this entire big array is a very, very difficult task. I don't know how to sort this entire big array. Okay. But I ask you, okay, let me divide this array into two parts, right? So my starting index is index 0. Ending index is index 7. So I compute the middle index, 0 plus 7 by 2. So what is 7 by 2? 7 by 2 is 3. Okay. So I tell you, hey, Adarsh, you know what? Can you sort this part of the array from index 0 till 3 to me? See, what is my end goal? My end goal is to sort this entire array from index 0 to 7. I tell you, boss, that is a very, very difficult job. But मैं तुमको बोलता हूँ, can you sort this part of the array for me from index 0 to 3? So somehow, let's say you call a function and magically you are able to see what is the job of merge sort. The job of the merge sort function, let's say, we'll write a function merge sort and I will pass, let's say, index LNR. So the job will be sort this entire array ARR from index L to R. So how will I call merge sort from the main method? I will call, can you please merge sort the array ARR from index 0 till index ARR dot length minus 1. I will be calling merge sort like this. So I will say, hey, can you please merge sort? What is the merge sort function doing? It will sort the array for you. So I ask, can you merge sort the array from index 0 till index 7? Now inside this, I say, boss, this is a very, very difficult task. But I ask you one thing. Can you sort this left part for me from index 0 till 3? Can you sort? I don't know how, but can you sort this left part of the array for me from index 0 till 3? So what I will do? I make a call to merge sort from 0 to 3. And I assume that magically the left part, let me denote the left part like this, A. Okay. So magically you assume that the left part of the array somehow becomes sorted. You call the merge sort function. See, what is the merge sort function doing? It is taking two indexes and it is sorting the entire array from index L till index R. So I say, boss, can you please sort the array from index 0 till 3? I call the merge sort function from index 0 till index 3. And I assume that once the merge sort function runs, magically from index 0 till 3 will get sorted. Okay. So how will my situation look? 2, 6, 8, 9. Now my left part of the array is sorted. This part is sorted. Now I say, boss, can you also sort the right part of the array for me? So I will call merge sort on the right part from index 5 till 7. And let us assume, sorry, from index 4 till 7, right? And let us assume that merge sort works magically and the right part also gets sorted. यही काम है ना merge sort का sort करना. तो मान लो कि merge sort magically sort कर दिया. So how will my right part look like? 3, 4, 5, 7. Now I ask you one question, guys. You will understand what needs to be done. I tell you, boss, you had to sort this entire big array. So I divided this array into two parts. And I say, boss, can you please sort the left part and can you please sort the right part? Let's assume that the left and the right parts are sorted. Merge sort works magically and the left and the right parts are sorted. Okay, so I have got the answer to the smaller sub problem. See, sorting the smaller array is a smaller sub problem. So I have got the answer to the two smaller sub problems. They have become sorted in themselves. Now, can you tell me how do I obtain the answer to my bigger problem if I know the answer to these smaller sub problems? Can anybody help me? This gives me the hint of recursion. The left and the right parts are now sorted, but actually I wanted to sort the entire array. So what I will do now, I will call my merge function. Hey, merge function, take this array ARR, index 0, index 3, index 7. Can you please merge the left and the right parts? And when the merging is performed, the entire array becomes sorted. So if I tell you once again, see what I'm telling. You have a very big array. You have a very, very big array to sort. Okay, very big array to sort. You say, boss, this is a very difficult task. I don't know how to sort this array. So you divide it into two parts. I break the array into two parts and I say, hey, Adarsh, can you please sort this array for me? How? Just call the merge sort function because the merge sort function is expected to sort the array for me. So I say, hey, Adarsh, can you sort this left smaller part of the array for me? Samajh lo, kar diya magically. Sorted this left part, right? So a smaller sub problem has been solved. And then I say, hey, Adarsh, can you also please sort the right sub part for me? I again call the merge sort function on the right part. Now, after the left and the right parts are individually sorted, is my job done? No, boss, my job is not done, right? Because the smaller sub problems have been solved, right? My job was to sort this entire array. But now I know the left part is sorted and the right part is sorted. So we have already studied a merge function. So now I will call my merge function. Hey, merge function, you have a left sorted part, you have a right sorted part. So can you please sort the entire array from index 0 till index 9? Are you getting what I'm trying to say? This left part is sorted, this right part is sorted. So now merge will work and this entire array will get sorted. How many of you are understanding the idea? I'll do a dry run also. Is this making sense? Yes. Got it? Okay, cool. So let me go to the code once. Okay, let us write the code for merge sort and then you will see how simple is the code for merge sort, right? And then we will try to trace the code. Okay, and then we will try to trace the code. Cool. Yes, Shrikant, correct. That's the base case, right? Show the last code. Yes, yes. Previous code is not working. Why not? Why not? It will work. Okay. Let us come here. Now, I will not touch my merge function, right? For your more clarity, just to make you sure that if you are clear with the merge function, I will reuse this thing, okay? So let us make a new tab here. Let's write the code for merge sort and then we'll do the analysis, right? Like, so let's just copy the merge function. So I have a magical merge function here, no problem in that, okay? Now I want to write a merge sort function, right? So public static, the return type is void, right? Because it will sort the array, okay? So the return type is void, okay? So let us write the function merge sort, merge sort. What it will take? It will take an array ARR. It will take an array ARR and it will take two indexes, int L, int R, okay? So what is this expected to do? The ideal expectation from this merge sort function is it needs to sort the array ARR from index L to R. Okay. The ideal expectation from this merge sort is that it will sort the array ARR from index L to R. ये sort कर देगा पूरा array को from index L to R. So now how do I call? Let's say just see int ARR. I make an array. Okay. Let us say I write here 8, 9, 6, 5, 3, 7, 10, random array, right? And I want to sort this array. So how do I call merge sort? I just call merge sort function. Hey, merge sort function, can you please sort the array ARR from index 0 till index ARR dot length -1. So this is a way of telling, hey, merge sort, can you please sort the entire array for me? Okay. And after this, I will just do a println of arrays dot toString ARR to check if it is sorted or not. Now let us focus inside this merge sort code, right? So I am asking you, this merge sort will basically sorting the array ARR from index L till index R, right? So guys, help me with one thing. 1 second. So let's say somebody calls this merge sort function and you have to sort this array from index L to R. Okay. Now, first of all, tell me guys, if L is equal to R, aisa socho, if index L and R are the same, then do you need to do any work? You have a single element array. Do you need to sort it? Soch ke batao. If L is equal to R, let's say you get a situation wherein L is equal to R, and I am asking merge sort, can you please sort the array from index L till R? If there is only one element in the part of the array, what is the need of sorting it? So you don't need to do anything. And think of one more thing, guys. If somehow L is greater than R, is it a valid case? L is the starting index. L is the starting index of the array. And R is the ending index, right? So L should always be less than equal to R. Do you agree? If L is greater than R, then you are not looking at a valid part of the array. मैं कुछ ऐसा बोल रहा हूँ बॉस कि my array is starting at index 5 and ending at index 3. ऐसा कभी हो सकता है क्या? Never. So do you all agree? For a valid part of the sub array, L should be less than equal to R. मानते हो? If L is greater than R, then we are not looking at a valid part of the array. Okay, because L is the starting index and R is the ending index. देखो ना, L is always less than or equal to R. Okay, and if L is equal to R, you just have a single element. Okay, so think of it like this. Think of it like this. Ki boss, if L is greater than, or let's say if L is greater than or equal to R, do you need to do anything? Do you need to do anything? Why ARR dot length -1? I want to sort the entire array. ये जो merge sort function है ना, this will sort the array from index L till R. So for L I have passed 0 and for R I have passed the last index. So it will sort the entire array for me. Now tell me guys, inside this merge sort function, okay, if L is greater than equal to R, that means either your array, either the part of the array that you are interested in, that is consisting of just one element, or the part of the array that you are looking at that is not even valid. So do I need to do anything in this case? This is my base case. You don't have to do anything. Simply return. Simply return. You don't have to do anything. Okay. This is the base case. If L is greater than equal to R, simply return. Okay. Now, if L is less than R, now when you come to line number 25, that means L is less than R. That means you are looking at a valid part of an array to sort. So what will I do? Boss, you have to sort the entire array from index L till index R. Very difficult problem at this point. So let us try to split it into two parts, right? So I will compute the middle index. Int mid is equal to L plus R by 2. So I compute the middle index. And now what do I say? Now I say that I have split the array into two parts, right? One part is from index L till mid and the other part is from index mid plus 1 till R. So मैं पहले बोलता हूँ, hey, boss, can you please sort the left part of the array for me? So I say, can you please sort the array ARR from index L till index mid? And what is merge sort expected to do? It will sort the array from index L till mid. मैं बोलता हूँ, भाई, can you please sort the left part from index L till mid? Now I assume that yes, your work is done. The left part is sorted. फिर मैं क्या बोलता हूँ, boss, can you also sort the right part for me? I have broken up into two smaller sub problems. Can you please sort the right part from index mid plus 1 till index R? Can you please sort the right part also? Now, once both the left and the right parts are sorted, I know that from index L till mid is a sorted part and from index mid plus 1 till R is a sorted part. So what do I need to do? My aim was to sort the entire array from index L till R. So what I will say? Now guys, try to understand. From index number L till mid is a sorted sequence. Okay. And from index number mid plus 1 till R is a sorted sequence. And I wanted ki boss, my merge sort was expected to sort from index L till R. So what I will do? I will simply call merge. I will simply call my merge function and say ARR and I will say the starting of the left part is L, the ending is mid, and I will pass R. So from index L till index R of array ARR will now get sorted. Job done, boss. Job done. यही काम था ना. What was merge sort expected to do? Sort from index number L till index number R. So what am I checking? First compute the middle index. Then I say, boss, can you sort the left part from L till mid for me? Can you then sort the right part from mid plus 1 till R for me? And then after the left and the right parts are sorted, I will call the merge function, which will make sure that from index L till index R of the main array becomes sorted. Okay, that's it, guys. That's it. Very, very simple code of merge sort. Now let us try to run it and see whether it works fine. What happened? Cannot find symbols. Okay, great. Because we didn't do an import java.util.star. Okay. 3, 5, 6, 7, 8, 9, 10. ठीक है. एक और element ले लेते हैं just to see it's working for both even and odd sized arrays. Let's try to run it. So 3, 4, 5, 6, 7, 8, 9, 10, right? So it is working fine. It is working fine, right? Now you will be interested in knowing boss हो क्या रहा है backend में. समझ में तो आ रहा है, ठीक है? How you have divided it and called the function, right? First of all, let me guys know, are you somehow getting this intuition what I am trying to do? My merge sort is expected to sort from index L till R. So I find the middle index. देखो मैं क्या कर रहा हूँ? See, first try to get the intuition, right? From my merge sort function is expected to sort from index L to R. I have to sort this entire array from index L to R. So what do? First of all, I compute the middle index. I compute mid is equals to L plus R by 2. Okay? How merge sort is sorting? Good question, right? Good question. Okay. Now try to understand. I have stated, boss, that you want to sort this entire array from L to R. I compute index mid. Now I say, boss, see, what is merge sort doing? Merge sort is taking two indexes and sorting the array in between these two indexes, right? So what do I say? Can you sort the left part for me? मैं बोलता हूँ, please sort the left part for me. So I call merge sort from index L till mid. Can you sort this part of the array from L to mid? Okay. So once this merge sort runs, I will expect from L to mid is sorted. Okay. This part is now sorted, let's assume. Okay. And then I say, can you sort the right part from index mid plus 1 till R? So I call the merge sort function and ask it, hey, can you please sort the array from mid plus 1 till R? So once the left and right parts have become sorted, what do I say? Now I will perform a merging. And when I call the merge function, I know that from L to mid is sorted, from mid plus 1 till R is sorted, right? So when I call the merge function, from index L till index R will become sorted of my original array ARR. Okay, that is what is happening. That is what my merge sort is expected to do. How is merge sort sorting? Okay. Okay, let's take an example, right? First of all, I'll take an example. Let me have a look at the chats. Why void and return are in the same function? Array, why they can't be? If the return type is void, you don't have to return any data type, right? But you can still have statements like return followed by semicolon, right? Return is just a way to tell that, boss, you don't have to do work in the function and the function terminates. We have seen these pieces of code before also, right? In a void function, you can have a return followed by semicolon. That is fine. You shouldn't be returning any data type. Okay. Why somewhere they give mid is equals to L plus R minus L by 2. They give it because if L and R are very large, right, then L plus R might overflow. Okay. ये binary search में तुम लोग पढ़ोगे, ठीक है? अभी के लिए L plus R by 2 चलेगा. You will read this in binary search that, boss, sometimes mid is also computed like this. Okay. Because what happens is, I will tell you briefly, what happens is if L and R are very, very big values, right, then L plus R will overflow. But here, even if L and R are very big, right, R minus L will be small. You divide by 2, that is even smaller, and you add a small number to L. So it will not overflow. But for now, you can assume that mid is computed like this, L plus R by 2. Okay. How is merge sort sorting? We will see that, right? This is helping merge sort to sort. दिखाता हूँ, पूरा dry run करता हूँ, ठीक है? और अदर कोई क्वेश्चन है क्या? Let me just take the questions first. In line 31, why 4 arguments when function have 3 parameters? How, boss? In line 31, I have passed 4 things, and if you look at the merge function, there are 4 parameters. Please count correctly. 4 ही है, कुछ अलग नहीं है. Okay. Okay. Line number 27. Line number 27 is just computing the mid. So let's say if I ask you, hey Adarsh, can you sort the array from index 5 till index 11 for me? So I will compute the middle index, which is 11 plus 5 by 2, that is 8. So मैं बोलूंगा first sort the array from index 5 till 8, then sort the array from index 9 till 11. See now, if I want to sort the array from index 5 till 11, what am I doing? I am computing the middle index, and I tell you, hey Adarsh, can you sort the array from index 5 till 8? Can you sort the array from index 9 till 11? And once these are both sorted, I will merge. So from index 5 till 11 of my main array will become sorted. Okay. Now let us try to do a run of this code, like what it is trying to do. I'll go to the PPT. I think we have gone quite into detail, right? I have never spent this much time on Mergesort before, but I just hope that spending time is worth it, right? And you guys are understanding, because that is our goal at the end of the day. थोड़ा time ज़्यादा दे दूंगा, मेरे को कोई problem नहीं है, but you should understand at the end of the day. Okay. So let's try to see how Mergesort actually works, right? So let us say you have this array. Right? I'm trying to see how Mergesort works. 8, 2, okay, 9, 6, 5, 3, 7, 4. Okay. I'll drop off today at 55, right? So we'll try to wrap it up a little bit early, right? So this is the array that I have to perform a Mergesort on. So how will I call Mergesort, guys? I'm trying to write here also. So I call Mergesort. Let us write MS. Okay. I will call Mergesort on array ARR. Okay. I will call Mergesort on array ARR. What is this index? This is index number 0, 1, 2, 3, 4, 5, 6, 7. So I will call, can you Mergesort the array ARR from index 0 till index 7? I have called this function, right? And now this function context starts running. Okay. So what you will see is 0 less than equal to 7? No. Okay. So see guys, you have this entire array to sort, right? From index number 0. Let's say this is L and this is R. Okay. You have to sort from index number 0 till index number 7. Okay. So definitely this is a valid part of an array which I have to sort. So what do? First of all, inside this function, I will be computing mid. Aisa socho, the context of this is running. So what will happen? First of all, you will compute mid. What is mid? Mid is L plus R by 2. What is 7 plus 0 by 2? 7 by 2 is 3. Okay. So mid will be at index number 3. So now what do I say? I say, hey, can you please merge sort the array from index L till index mid? Here mid ka value is 3. So from index 0 till index 3. So what I will say? Let's try to understand. I will say, hey Adarsh, can you please sort the part of the array? Can you please sort the part of the array from index 0 till index 3? And now a new function starts running. I'm just drawing here. Mergesort ARR 0, 3. Okay. And now guys, try to understand. I have drawn here. तुमको ऐसा लग रहा होगा कि I have drawn here a second array, right? But this is the same array ARR from index 0 to 3. I have zoomed up and tried to draw, right? So whatever changes I make here, basically there is only one array and the changes will get reflected there. Okay. So now I say, hey Adarsh, see, I wanted to sort this entire big array from index 0 till 7. So I computed mid, which was index number 3. So I asked, can you please sort this array from index 0 till 3? And now we are focusing on this part of the array. Okay. Again, what is L here? L is equal to 0 and R is equal to 3. So what I will do? Again, we compute mid. What is mid? L plus R by 2. So 0 plus 3 by 2 is 3 by 2. That is index number 1. So I say this is my mid. This is my mid. So I say, I call, can you please merge sort the array from index L till mid? So from index 0 till index 1. So I say, hey, can you please sort the left part of the array from index number 0 till index number 1? And then what will happen? I will pause here. Okay. A new context starts running. I'm trying to just show you the context as well. 0, 1. Now I am here, right? I am here. I want to sort the array from index 0 till 1. Okay. Again, this is a problem. And it is not the base case, right? Because the array is consisting of 2 elements at this point of time. So what do? L here is 0, R here is 1. So I first of all compute mid, which is 0 plus 1 by 2. So mid will be at 0 only here. Okay. So mid is equal to 0. So now what do I say? Can you sort the left part? So I will make a call to merge sort from index number 0 till index number 0. L is also 0 and mid is also 0. So I will say, can you sort the left part of the array from index number 0 till index number 0. So a new context will get created for merge sort 0, 0. Okay. I'll not draw context more. Now you will have to follow, right? There's no more space. Okay. So now when this is running, what do I see? L is 0 and R is 0. So L is less, greater than or equal to R. So now I am looking at the part of the array that is consisting of a single element. So do I need to do anything? No. So I simply return. I simply return from here. I simply return from here. I simply return, right? I simply return. हो गया आपका काम. Then what I will say, the left part is sorted from index 0 till index 0. Correct है, sorted है. Now I will say, can you sort the right part of the array? The next line is, can you sort the right part of the array? From index mid plus 1 till index R. So I will call merge sort on 1, 1. So I will call it on the right part from mid plus 1 till R. Okay. So from index 1 till 1. Again, this is a single element. So I don't have to do anything, right? L is greater than equal to R. So I simply return. I simply return. Okay. Now see guys, try to understand. You wanted to sort from index 0 till 1. And you see that from index 0 till 0, the left part is sorted and the right part is also sorted from index 1 till index 1. Now, after these two merge sort are called, please focus here. What was the next line of code that we had written? Merge. So now I will be calling the merge function. And what I will pass, can you merge the array ARR? The left part is from index number L till index number mid. So the left part is from index 0 till 0. And the right part is from mid plus 1 till R. That is from index number 1 till 1. So now guys, try to understand. When I call the merge function and I pass 0, 0, 1. What is L? L is 0. What is mid? Mid is 0. And what is R? R is 1. So I call L, mid, R. I have passed. So now can I assume guys, the merge function that we have written, that will, make a new temporary array, perform the merging. But at the end of the day, from index 0 till index 1 of array ARR will become sorted. So here you will, when you perform a merging, what will happen? Here 2 will come, here 8 will come. यहाँ तक सबको समझ आ रहा है. This is the important part. See, you needed to sort from index 0 to 7. I broke it up and I say, hey, Adarsh, can you sort the left part of the array from index 0 till index 3? Okay. Now, again, this is a bigger problem. I break it up. I find the middle. 0 plus 3 by 2 is 1. So I say, can you please sort the left part of the array from index 0 till index 1? Okay. Again, what I will do, I compute the mid. What is 0 plus 1 by 2? It is 0. So I will say, can you sort the left part from index 0 till index 0? Okay. Now what happens? Try to understand, guys. This is the base case. Okay. So when I want to sort the array from index 0 till index 0, this is a single element. So what will you sort? So you simply return. Then I say, boss, I wanted to sort from index 0 till 1. So I have sorted the left part, okay, from index 0 till 0. So now I will call merge sort on the right part from index mid plus 1, which is 1, till index number R, which is also 1, right? So I call merge sort on the right part, 1, 1. This is also a base case, so I return. Now, once I have sorted, now see guys, try to understand. I'll draw it here for your more clarity. We were inside merge sort of 0, 1. I wanted to sort the array from index 0 till index 1. Okay. So L is 0, R is 1, and mid will also be 0. So first of all, I call, can you sort the left part from index L to mid? So merge sort was called on 0, 0, and that simply returned. Then I say, can you sort the right part of the array from mid plus 1 till R? So I called it from 1, 1, and this also returned. Now I know that from L till mid is a sorted sequence, and from mid plus 1 till R is also a sorted sequence. So now I will call a merge function, merge ARR, and I will pass L, mid, R. So 0, 0, 1. So when this is called, what was our merge function doing? See, we are in the same assumption, right? From L to mid is sorted, and from mid plus 1 to R is sorted. So when I call merge on L, mid, R, from index L till index R, that is from index 0 till index 1 of the ARR, will become sorted. So 2 comes here and 8 comes here. Merging will happen, and this is how we look like. Okay. And see guys, I am making the change here, but you understand, when you write 2 and 8 here, now the changes are taking place in the original array only. Because even though I have drawn 2, 3 different parts for you, right? They are a part of the same array that we are talking of. Okay. So now my left part is sorted, right? So merge sort 0, 1 now returns. Now I come back to merge sort 0, 3. So I wanted to sort this part of the array from index 0 till 3. Okay. And guys, try to understand, here there is already a 2 and 8, right? I'm not just making sure it's coming here. Okay. So now the left part is sorted, merge sort of 0, 1 has been done. And you see that from index 0 till 1 is sorted. Now I say, hey, can you please sort the right part of the array from mid plus 1 till r? So what is mid plus 1? Index 2. And what is r? 3. So I will say, hey, can you sort the array from index number 2 to index number 3? So I will call, after this line, I call merge sort 2, 3. Can you sort this part of the array? Now what will happen? Again, this is a big problem to solve. So again, I will compute mid. What is mid for this case? 2 plus 3 by 2. That is 5 by 2, which is 2. So mid is at index 2 itself, right? So I will say, can you please sort? I will make a merge sort call to the left part from L till mid. So it will make a call to 2, 2. Merge sort 2, 2. And this is a single element, so I will return. Then it will say, okay, the left part is now sorted. Can you please sort the right part? So I will make a merge sort call on the right part. That is from mid plus 1, which is 3, till r, which is also 3. So I will make a merge sort call on 3, 3, and this also returns. Now, once I know that the left and right parts are sorted, see, from L till mid, that is from index 2 till index 2 is sorted. And from mid plus 1 till r, that is from index 3 till index 3 is sorted. So next what I will do, after these two are done, I will call here merge and I will pass boss. What is L? Sorry, we were in merge sort of 2, 3, right? So here what I will next call? I will call merge and I will say, what is L? L is 2. What is mid? Mid is also 2. What is R? R is 3. So 2, 2, 3. So when I call the merge function, this 9 and 6 will get merged. And here you will get a 6. Here you will get a 9. Okay. And once I return from MS of 2, 3, now you come back to MS 0, 3. Now see guys, the left part from index 0 to 1 is sorted from L till mid. The right part from index 2 to 3 is sorted. Okay. Now I will call the merge function. And what I will pass? L, mid, R. So what is L? L is 0. What is mid? Mid is index 1. And what is R? R is index 3. Okay. So I know from index 0 till 1 is a sorted part. From mid plus 1, dekho, from mid plus 1, right? When you write 6 and 9 here, actually the change is getting here, right? 6, 9. So from mid plus 1 till R is a sorted sequence, right? So when I call the merge method, what will happen? The array ARR from index 0 till index 3 will get sorted. So when I call a merge function, these two smaller subparts will get merged. And here you will get a 2, 6, 8, 9. So the left part of the array has become sorted. And when I write 2, 6, 8, 9 here, try to understand, guys, it is being changed in the array object. There is only one array, right? Okay. Now I say the left part is sorted. Now try to understand, guys. This returns. So the left part, ARR 0, 3 is sorted. If you see the left part of the array from index 0 till index 3 is sorted. So now I'll just quickly wrap up. I call merge sort on the right part. Okay. Boss, can you please sort the array from index mid plus 1? That is, can you sort from index number 4 till index number 7? Okay, I've called merge sort here. Then again, this is a bigger problem. So I compute mid. What is mid? 7 plus 4, 11 by 2, that is 5. So mid is here. Okay. So I say, can you please sort the left part from index L till mid? That is, can you sort the part from index 4 till index 5? Okay. Again, this is a bigger problem. I will say, find mid. What is mid? 5 plus 4 by 2, 9 by 2 is 4. So I will say, can you sort the left part from index number L, which was 4, till mid, which is also 4. This is a single array, single element, return. Can you sort the right part? Single element, return. Then I will perform a merging, 4, 4, 5. So when merging happens, these two elements will be merged. And here you will have a 3, here you will have a 5. Okay. So 3, 5 ho gaya, right? It's reflected everywhere, right? Try to understand. Now, then what will happen? I say, boss, the left part is sorted. Can you sort the right part? So I will say, please sort the right part. Again, this is a bigger problem. I will break it up. 7 already sorted. 4 already sorted. I will perform a merging. Now, when I perform a merging, you will get a 4 and a 7 here. That is a 4 and a 7 here. Now, see guys, try to understand. From L till mid is sorted. From mid plus 1 till R is sorted. So now I will call the merge function for this array. Okay. So what will happen? When I merge, right? 3, 5, 4, 7. So what will happen? Here you will get a 3, 4, 5, 7. Ho gaya merging. Then the left part and the right part are sorted. So now I will call a merge on this. So when I merge these two, what will happen? 2, 3, 4, 5, 6. From index, see, now from index 0 to 3 is sorted. And from index 4 till 7 is sorted, right? So I will make a merge call on index 0, which is L, mid, which is 3, and the ending index, which is 7. So from index 0 till index 7 of the array ARR will become sorted. How many of you followed what was happening? I will ask all of you to try to do a dry run of the code, what is happening, right? and then try to, you know, come up with it, right? Bounce, okay. So confused. Oh, I am pretty sure many people will get confused in the first attempt, right? But what I will ask, I'll repeat it again tomorrow, right? I will repeat it again tomorrow, right? But what I want you guys to do it, please try to do a dry run of this recursion. You know how to do recursive dry runs, okay? So please do the dry run once, okay? And then tomorrow you will understand it even better. Once you think over it now, you will understand it even better. So guys, quickly I will ask you to vote in how much you have understood the concept of today's class. Just quickly vote in and we'll end the class, right? I'll just share the link. Just vote in. Overall, the contents of the class, have you understood today? If yes, we will spend another 30 minutes to 40 minutes tomorrow on Mergesort, right? And you know, then we will wrap up with, and then we'll go with quicksort, right? So just quickly cast a vote and then we are done with the session, right? And yeah, for this recursive merge sort, I will ask everyone to do a dry run once yourself, right? एक बार पूरा समझो कि क्या हो रहा है. Try to make, you know, a recursion tree like this that I have done and try to see with the context what is happening. You will definitely able to understand, right? Tomorrow, I will repeat this thing once again, this diagram, okay? Then we will do the time and space complexity analysis and then we will move on, okay, with quicksort, okay? Okay, so I see it's almost an 80-20 and that's good, I would say, because merge sort is a little bit complex topic. So if you are 80-20, I am pretty happy. And I will hope that the people who are in the no category, right, these 19% of the folks, right, please try to put in some effort and try to do a dry run of the recursive code yourself. You will see that it somewhat makes sense. Start with the very basics. First of all, be sure that you are 100% clear with the merge. Because if you are not 100% clear with the merge, you can never be clear with merge sort, right? So पहले merge के साथ clear हो, and once you are clear with merge, then only go and proceed with merge sort. Otherwise, don't even look at merge sort. पहले merge के साथ clear करो कि merge कर क्या रहा है. Okay? Cool guys. Hopefully you guys enjoyed today's session and you know we broke it up into, you know, smaller and smaller chunks. So I'll stop the recording